All right, guys, we got a fairly quick one for you today. Let's fire it up. Okay, well, don't mind me. I'm a little bit filthy today. This is some good clean work we got going today. Customer just dropped these off, and what they are is some mighty large sockets. So it's 1.5 inch drive. It's a 2 3/8 socket. And so I've got 2 that are 1.5 inch drive and then 2 that are 1 inch drive. Now, what the customer wants me to do is they want me to take one of them, they want me to keep. The other one they want me to cut off as deep as I can go, and they want me to weld the 2 together so that they can have a deep socket. You can see that this is not very deep. It looks deep, but it's not deep. So that's the plan. So my plan is I'm going to take this one. I've already taken a measurement on the depth here, and I want to be just past that groove because I'm going to true this up with the lathe. But I want to put this in the bandsaw. I'm interested to see how the bandsaw cuts this material. We're going to go ahead and cut it. It's definitely hard steel, so I'm probably going to have to slow it down and change the band speed. But it should cut it, I hope. So I'm going to go ahead and I'm going to get this in the bandsaw. Let's see how she cuts. And in case you're wondering, yes, I'm still loving the bandsaw. Should be good there. Fire in the hole. Now, before I cut, I am going to check bandsaw speeds. Okay, so it looks like about 220 is what the chart says. Got the fluid flowing good, and then I'm going to just make sure we're cutting good and slow here. Seems like it's cutting good. Boy, she's cutting nice and smooth, nice and quiet. Sounds good. That was pretty satisfying. I'll show you guys. Look how good that cut looks. My goodness. It's freaking beautiful. You can see that it is very consistent on the inside. So that's what I wanted to do. I wanted to leave just a little bit of a lip there because I'm going to machine this down to where all I have left is just the hex, and then on the outside I'm going to put a bevel on it so that I can weld it up, and then the outside will look just like it did before. So got that one cut. I am going to grab that other 1 inch drive set, and I'm going to cut the one that I need to cut. When we get ready to go over to the lathe and start machining these, we'll come back to you. Okay, so we got both of these cut. Here's the second one we cut. You can see there is a little bit of a lip. Hopefully you can see that. There's a little bit of a lip right there. There, you can see it in there. You can see there's a little bit of a lip up in there. Okay, so that's what I wanted. So I want to be able to machine this down and get a nice bevel on this so that when I go to weld both halves, I can put them together, they both have a nice bevel on them, and then I can fill it up with weld. Now, I'm trying to decide if I wanted to be quick with this job, I would probably just weld it up with dual shield, but this is a job that I've already given the customer a quote, so it's a set price. And so I'm not worried about time as much on this one. I do think that this would be a great test for the new ArcCaptain ArcForge 250 with TIG. So I think what I'm gonna do is probably TIG weld this. I would also like to walk the cup a little bit because I haven't done it on anything for a while, and I want to try to stay sharp with that, so I think it'll be some good practice. So I think that's what I'm gonna do. The next order of business, we're gonna put this in the chuck. For those of you who don't know a whole lot about machining, not all chucks are created equal. So some chucks you can flip the jaws in with these 2 bolts here. I'll give you guys an up close look, but there's some chucks out there where you have to actually back the jaws all the way out and then flip them around and then run them all the way back in, and it's kind of a pain in the butt. Now, I did purchase a new gator chuck for this lathe about, I don't know, a year or 2 ago, and I've been loving it. And one of the things that I really like is that this chuck has the Allen bolts in it, so that I can just pull those, flip the jaw, put the bolts back in, and I can keep going. So let me show you guys what I mean. Okay, so you can see there's those 2 bolts there. So if I pull these 2 bolts, this jaw will pop off, and then I can flip it around. That way I can bite my workpiece from the outside instead of biting it from the inside like I have here. I have tried biting it from the inside, and it just doesn't run true. So I think I'm gonna get better results biting it from the outside, especially where the outside is the surface that matters to me, because I'm trying to get both ODs to match up perfectly or close to it so that I can weld them up and get a nice pretty weld joint. So let's flip these jaws. Okay, now when I have these off, I consider it a good opportunity to clean off the chuck and try to get some of this metal out of here. So I take some brake cleaner and I'll actually just kind of hose that down and make sure to wipe that off. And that'll usually blast a lot of the metal shavings and stuff that I don't want in there out. And then I'll go ahead and do the same to the jaw. There gets to be so much gunk and metal shavings and stuff in there. Whoo, that feels good in my cut. If you haven't tried brake cleaner in an open wound, I highly recommend it. So now that's nice and clean. Now I'm going to flip it around. Oh yeah, that fits perfect. You can always tell when it's too dirty because you kind of have to fight it sometimes if you got metal shavings in there. So it's always a good idea to just clean it while you have it off. It's a perfect opportunity. Clean off your hardware. And then I don't go too crazy with these, just good and snug. Okay, so you can see this jaw has been flipped. So I got to do that to these 2. When I get that done, we'll come back to you. So we got this chucked in, spinning nice and true, or true enough to just get a weld joint. So first thing we're going to do is we're just going to face this off until we get rid of that little groove right there. I'm going to grab some safety glasses. Okay, here we go. Hey, a little overzealous there. Okay, I think that's going to be a little bit fast for this type of material. I'm going to drop it down just a little bit. That's better. There we go. I like to try to keep that out of the way if I can. You get those big bird nests right there. Eventually they get so big they start flipping right in your face. So if you can keep it from getting that big, it's a lot safer. It's looking pretty good. A little bit more. And you definitely don't want to touch these because they get freaking hot. And they're razor freaking sharp, so you just want to use some pliers. I like to just keep them feeding down through the lathe here into the bed so I can keep it from turning into a big bird nest that smacks me in the face. We're getting dang close. It's not quite there. Okay, so I got that all cleaned up. I am gonna clean up right in the corner of the hex. It's gonna be hard to get that with a lathe tool, just because it's a circle. There's always going to be material in the corners unless I cut a whole bunch of material out to get to it, which I don't want to do. So now all I need to do is bevel it. So I'm going to do a 30-degree bevel here. So I've got to switch my compound. If you're not familiar with the lathe, this is your compound. Alright, so I've got my tool switched over, and I've got it put in my tool post on the back side here. I'm going to use my compound here to cut the 30-degree bevel in this material. So you just turn this little knobber right here. I think we can go just a little bit further. Okay, by the time I get those corners cleaned up, I think that's going to be good. That is just a little bit warm. Okay, so you can see there's still some material in there. I'm just going to hit these with a file and get that material out of those corners. And so my land, you can see kind of right there on that corner. I think you can see it right there. So there's just a teeny bit of land right there, which is about what I want. I'm pretty happy with that. Okay, so I've got that side done. Now all I need to do is take the existing socket that they're going to use with the drive side on it, and I'm going to take and put a 30-degree bevel on the, let me just show you, goodness. Okay, so now all that's left to do is I'm going to take this socket, which they're going to use the drive end on this socket, and then I'm going to put a 30-degree bevel here. That way, when I put these together, they'll mate up. That's the wrong one. But you guys get what I'm saying. When I mate those up, there's going to be a bevel. Okay, so I'll be able to weld those up. Now I'm going to take these socket pieces, I'll put them in the lathe, we'll get a 30-degree bevel on there, get everything prepped up. The customer is going to bring me a nut tomorrow, just so I can make sure that the nut slides down in there and everything is lined up when I get it tacked up, so that I don't get it twisted and then the nut doesn't go in all the way. That would be bad news. So that's pretty much where we're at. So once I get these parts all machined and ready to go, ready to fit up and weld, I'll come back to you and show you how the fit looks. Okay, weld prep. Beveled, 30-degree bevel on both. Should give us a nice pretty weld when we're done. Well, should give us a nice pretty joint. The weld part is yet to be seen. That'll give us 100% pen, or close to it. I guess we technically don't really want to be 100% pen, because then we'll interfere with where the nut's going to go on the inside. So that's part of the reason that I left a little bit of a land in there, and it's also the reason that when I weld it up, I'm going to weld it up flush. I'm not going to gap it at all, and we'll get them tacked up like that, and then we'll fill that up with weld. I'm pretty sure that's probably the biggest deep well socket I've ever seen, or it will be when we're done. Kind of a cool little project. Anyway, well, those are prepped up and ready to go. I am going to wait until tomorrow until the customer brings me a nut, or if he doesn't bring me a nut, we'll move forward. But he told me he would bring me a nut tomorrow, and we would be able to check it and test it while we get it tacked up and welded out. So just to make sure that there's no issues with the nut sliding all the way to the bottom of the well. So for now, that's going to be it. We'll catch up with you guys tomorrow when we get that nut here. Okay guys, we are getting ready to get our ArcForge 250 set up with the TIG rig here. So This is the style of TIG rig that you guys are going to want. If you're running this type of machine, you want a TIG rig that has the DIN style with the gas hose coming off of it. So you should be able to get a similar setup. Even if you're not running an ArcCaptain setup, you can get a setup like this at your local welding store that has this style DINS connector. You can plug it in, and then you plug this into your gas bottle regulator, and then just set up your torch the way you want. So I am using the ArcCaptain setup. See, I got my torch set up here. I'm using a Furic number 7 Pro cup. Got a gas lens in there, and I got the short back cap on it. Okay, so we're gonna get this set up here. Now, running DC TIG. Okay, so we're gonna get our rig set up here. So it's really simple with this style setup. You just take your DINS connector, and with DC TIG, we're gonna run DC electrode negative. So I'm gonna plug my TIG rig here into the negative side, and then I'm gonna take my ground plug and I'm gonna plug it into the positive side, and now I should be set up for DC TIG. So I have not ran DC TIG on this yet. This is the first time that I will have tried this. A little advice I would give you, especially with a machine like this, that it might be kind of hard to dial in your settings. One thing I'll do is I'll take a picture. That way I know. That's the other reason I think it would be nice if this was your wire feed, because you could just either take a picture of the numbers, but you need to know where this dial is so that you know where you want your wire feed speed to be, where you like it anyway. So I know I'm 19.5 volts, and I know I'm running right there on the dial, so that's why I took a picture of it. So if I come back and I want to weld the same settings, I can start right there. Okay, here we go. We're gonna switch our switch to TIG. So we're gonna go off of amperage now, and I'm assuming that this is gonna change that. Yeah, see, this is exactly what we should have for our wire feed here. It should be a readout for this when you're in MIG, and then when you're in TIG, this is the readout for your amperage. So, you know, it should match, which it's right on the money. If I go to 130 here, it says I can get it dialed in, and it will match whatever's on the physical dial here. So we're gonna start at, this is pretty heavy material. Let's go 125. We'll start at 125 amps. And then I'm gonna get my gas hose hooked up. So I'm gonna hook up my argon bottle and my regulator and get set up, and we'll be ready to start tacking these up. Okay guys, so I've got my 2 halves here of my socket. So I'm gonna have to get this lined up. I don't believe the customer got me a nut, which it's okay. I should be able to get it lined up next to perfect without it. So we're gonna get these tacked up. Then we're gonna use our weld positioner. I'm gonna put the socket in the weld positioner, and then I'll be able to walk the cup on this, and well, hopefully, it's been a minute. So we'll go ahead and weld these out today with some ER70 S6 332 rod. If you don't know what I'm talking about, it's the grade of rod. So ER70, probably won't be able to see that, but on TIG rod you can see right there ER70 S6. Okay, so it's mild steel rod. Yes, I'm sure I'm gonna get some comments that that's gonna change the temper on the steel. I know it is, but this is what the customer wants, and so sometimes what the customer wants, the customer gets. We're gonna go ahead and we're gonna tack these up. So here's the TIG setup. Okay, so there's my TIG torch. If you haven't seen this kind of setup, it's just got a manual gas valve on the back. You just crack that open. You can hear the gas running. Okay, and then when you're done, you just close the valve. So instead of it operating off of a solenoid valve that is built into the machine or that runs off your foot pedal, you are the solenoid valve. I operate the gas. I turn the valve on, I turn the valve off when I'm done. So just so you guys understand that. So let's go ahead and get the socket tacked here, and then we'll put this in the weld positioner and see if we can't get some weld in this baby. Okay, so there's several different ways that one could do this. You could take a piece of angle, you could lay the socket pieces in the angle so that the outside is concentric. I'm kind of doing the same thing here, only I've got these fancy vice grip dealios that have some pipe jaws on them, and so that holds things concentric as well. So now I'm just looking down the barrel of this and I'm just checking to see if we are in line, if everything feels in line. Gosh, it looks pretty dang good. So I'm here to tell you, I'm pretty sure I could spend my life savings at Fireball Tool. Okay, so to be honest, I feel like I can get this in line better by just moving it where I want it and checking all the 6 surfaces to make sure they're in line. We're ready to put a tack on this. Okay, so this is the first arc strike with the ArcCaptain ArcForge 250. Let's see how this goes. I'm going to clamp it down. Now I'm going to get a tack on the opposite side here, if I can. Okay, I do think that with the ArcCaptains, you want to be pretty aggressive snapping out of your arc. So hopefully you can see in there. Looks pretty good. So hopefully you can see that's good and lined up. Okay, so I am going to take and put 2 more tacks. So I've got tacks on every 90 degrees. Yeah, you're a lot better to snap out fast. Much better. And I've noticed that when you start the arc, it kind of has a little hesitation, so it starts with maybe, I don't know, 50 amps and then increases after that. I feel like we're in good shape. Okay guys, so here's what my plan is. If I turn my weld positioner on, you can see that it's going to spin. Now, like I said, I've got this number 7 cup in here, and I'm just going to kind of wiggle the cup right here and blind myself. Goodness! I'm just going to kind of wiggle the cup like this as I go around. And you can either walk it on the corners like that, or a lot of people will just kind of slide it. See how I'm kind of sliding that porcelain through there? So I may try to slide it like that, see how it goes. It's kind of tricky because sometimes the porcelain or the ceramic kind of grabs. Anyway, that's our plan. We're going to try it, see how it goes. I'm going to wait till that next tack comes around, start there. Okay, I can already tell that's too cold. I'm going to kick it up to 150. 150 amps. Here we go. Running a little bit fast. So So I turned that down a little bit. Now we're getting there. Okay, trying to get the speed and everything adjusted just right. It's a little bit tricky, but we're getting there. I'm also trying to figure out how to put this. This hose is a little bit stiff. I'd like it if it was a little bit more flexible, but that's good. Just trying to get comfortable. Okay, so something to note. I told you guys before that when you light the arc up, it hesitates for a second and then it comes on whatever you have the amperage set to. So it starts at like 50 amps and then it ramps up to, you know, I've got it set to 150. So it's just, you got to keep in mind, if you dip the tungsten or you touch your TIG rod or whatever, when it cuts out, it takes a second for it to ramp back up. It's not a huge deal, but when you're welding with a weld positioner, there's a delay in time. So just keep that in mind, that it does take a second. Most TIG welders, you don't have that delay. And so it might cut out for a second, but it just goes right back to full amperage. So you're not having to wait for it to ramp back up to keep the puddle flowing. So just keep in mind there is that little bit of a delay. It's not a huge deal. It's not a deal breaker. It's just something you need to be aware of. Torch is getting a little bit hot. Okay, so I'm going to show you guys what it looks like. Now this wasn't the best start because I went for a while and it went really good and then I had to stop. Most of that was my fault because I'm trying to get the speed adjusted right on the weld positioner. But you can kind of see, you can see what the machine's capable of. Alright, so you can see it went really good right there. Then you can see I had some stops right there, trying to get the speed adjusted. And then it went really good there for quite a while. It is running well. The arc is nice and smooth. No complaints there. I am curious with a machine this size, with what it's capable of TIG welding, you know, a 250 amp machine. I do wonder if ArcCaptain is going to come out with a liquid cooled torch and a liquid cooler. It would be, I think it would be wise on their part, because to put that kind of heat through the torch for something where you're going to be welding, like if you were welding pipe with this and you were just welding one after another, that torch is probably going to get so hot that you're going to have to stop and wait for it to cool down. So if they were to come out with a liquid cooler and a liquid cooled TIG torch setup, I think that would be a plus, but we'll see what happens. I may be able to fill this up with one more pass. We're going to see how it goes. If not, then we'll run one more filler pass and then we'll do a cap pass on top of that. Okay, this is going to be a filler pass. I can already tell you it's not going to fill up enough, which is okay. It's good practice. I'm hoping I can keep moving fast enough that I don't have to stop and readjust the speed on my weld positioner. Seems like it's going okay. Whew. Okay, this torch is getting so hot that it's kind of getting hot on my shoulder. And if I put that on my face, I don't think you'd want to hold on to that with your bare hand. It's pretty, oh yeah, yeah, she's getting hot. So we're gonna have to stop, let that cool down. That's why I say, I think with this size of machine, if you're gonna use it as a heavy duty machine for TIG welding, if you're gonna do heavy duty work with this machine for TIG welding, you're gonna want a liquid cooled setup. So I don't know if ArcCaptain plans on coming out with that or not, but I can tell you, even welding at 150 amps, this sucker's getting hot. So we've got to stop and wait for this to cool down before we can continue, because it's toasty. But I can show you what that second pass looks like. Okay, second pass looking good. I'm liking it. So it does run nice and smooth. The only complaint I have so far is the torch is getting hot. Too hot to hold, so that's probably something that's going to have to be remedied. So we'll let this cool down, and then we'll finish the second pass, and then when we get ready to run our third pass, we'll come back to you guys. I did have to wait for this to cool for 15 minutes before it was cool enough that I could actually hold it. So that is definitely something that needs to get remedied by ArcCaptain, I think. That's why we do tests like these, so we know. So I'm gonna run the finish pass now. I'm hoping I can make it all the way around without having to stop to wait for it to cool down. So let's see how this goes with our cap pass here. Okay, so that was getting a little bit away from me, meaning my speed on my weld positioner was a little bit too fast, and I started getting down here and I ended up slipping. The torch is definitely heating up again, but I only have about 1.5 inches to go, so I'm just going to go ahead and run this, and hopefully I don't burn my shoulder in the process. Okay, it was getting hot. I can still hold on to it, but it's definitely south of warm. So I did get it finished up, and I am really happy with how it looks. I'll go ahead and show you guys. Okay, it's looking pretty good. So the arc is definitely smooth. It welds good. So I am happy with that. The only thing I'd be unhappy with is I just think that this is a big machine, and if you're welding heavy duty things like this, you're going to need a liquid cooled setup, because it's not practical that if you're using this in a fab shop or somewhere where you're doing heavy duty work, it's not practical to set your torch down and go eat bonbons or something for 15 minutes while you have to wait for your torch to cool. So that would be my one complaint. Other than that, everything runs smooth. The torch operates the way it's supposed to. The gas valve works good. I like the diameter of the torch handle. It feels good to walk the cup with. Everything's good, other than I just think it needs to be cooled, and that's normal. So for this kind of work, you're gonna want some kind of liquid cooler to keep your torch cool. So that tells the story right there. The machine is capable. It welds well. I'm happy with it. The The only thing left to test on the ArcForge 250 is going to be the stick capabilities. So now we've tested our TIG capabilities. I'm happy with it. I do think that it needs a liquid cooler, but as far as the machine performance goes, it went great. So on the next one, we'll tackle the stick capabilities. So I'm going to get this other socket welded out, but it's just going to be the same process. So I hope you guys enjoyed this video. If you did, please like, subscribe, and share. I did want to add, I am going to throw this out there. If you guys are interested in Freedom Fab swag, meaning hats, shirts, stickers, long sleeve shirts, there's some hoodies. We are going to try this out. I don't have like a store set up yet, but I do just kind of want to throw some feelers out there to see who's interested. So if you are interested, you can send an email. I'll leave the email on the screen right here. You can send an email to this email, and if you send an email, my wife is the one that's kind of running things as far as the swag goes, so she will send you a link where you can get on there and you can see what our pricing, availability with colors and styles is. And then if you're interested, you send an email back to her saying this is what I want, and she can help you submit that order and tell you what it's going to be with shipping and everything. So we're just kind of putting feelers out there to see if there's that much demand for Freedom Fab swag. So if you're interested, check it out. We appreciate the support. Hope you guys enjoyed it. Thanks for watching. See you on the next one. I do think this would be a great test for the new ArcCaptain, There's always going to be material in the corner unless I Alright, so I've got this all switched out. My tool is on the front, I guess the back side of my tool post here. Blah, blah. You could take a piece of angle and you could lay the two pieces of socket. I like the diameter of the rod. Goodness. Hope you guys enjoyed this one. Hope you guys learned something. Hope you guys enjoyed this video. Hope you guys learned something. If you did like it, please like, subscribe, and share. Goodness.